So yeah, hi guys, let's start with the chapter 4. This is because we are going to pick up where we had left on an earlier class. I had told you that we are going to pick with the chapter 4. So remember, whatever you have learned up till your chapter 3, each and everything that is required while you are doing your chapter 4. And remember, this is the chapter which is linear equation in two variables. Although for your level for class 9, this is quite easy. You just have to plot the points. You don't have to do much about this. But the main thing is that you have to do what? You have to keep in mind how you're going to build up linear equations, because while you are in your class 10, you guys will be having various methods to solve linear equation in two variables. Remember, for now, you won't be having those methods where you are going to learn to find out exact values for the value of finite x and finite y. But here in this case, we are going to use just one equation and have as many solutions as we want for that equation and plot them on graph. But while we are in class 10, you guys are in class 10, you guys will be understanding various methods, your elimination method, your substitution method, your cross multiplication. You will be having various methods there to solve your linear equations in two variables. But for now, we are going to learn actually what are linear equations, what are linear equations in two variables, and what are everything else that we have to do with this, how we are going to plot them in a graph. So guys, before we attempt this one, I highly recommend you guys to just remember and recall each and everything that you have learned in your class in your chapter 3. Remember, you guys should be understanding the concept of plotting. So you guys must be knowing coordinates. You must be knowing how to plot them, how many quadrants are there, what is the scenario when a point is lying on x-axis or y-axis. So you guys all must be remembering those points, and I hope you guys already remember. So I'm going to do what? I'm going to start with this, and let's see what do we have the very first. So we have the content slide here. So I will be explaining the introduction of this chapter. We will be understanding linear equations. We will be having solutions of linear equations. Then we are going to discuss how we are going to plot a linear equation in one variable and how we are going to plot linear equation in two variables. And then we are going to consider the cases where we have been given only the values of x or y's. So we are going to understand some those cases, and we are going to have some questions in between, and later we are going to study a summary. So remember, this chapter is not that much lengthy. Like you guys remember, in a chapter 3 we had just completed that chapter under one sitting, right? So this chapter will too be, I think, be completed in just one sitting. So remember, this is not lengthy, but this is interesting. Remember, here you are going to learn how you are going to form linear equations, whether they are in one variable or two variable. You are going to recall everything that you have learned in your class 8, where you had linear equations in one variable. You had formed linear equations for various statement sums, right? You guys remember those, right? So we are going to use them. We are going to move to two variables, and then we are going to plot them on graph. So remember, this is what we have to do, and let's just see. Before we get to the point, you guys should be remembering what is an equation, what is a linear equation, what is a variable. So while we were in chapter 2, I had told you that there is a fine difference between algebraic expression and algebraic equation. Do you guys remember what was the difference? If you are watching this video later on, you can just answer them then. See, the difference between both of these is just this one, that an equation actually gives you any answer. It should be giving you any answer. Let's say a. If I have something like this, if I have an algebraic expression which is 2x plus 1, if I add equality to it, and let's say I get a 10 here. So this is what? This is an algebraic equation, whereas only 2x plus 1, that was an algebraic expression. So remember, expression is just a mathematical form of your statement that you have been given, right? You guys remember, let's say if I take this example, let's say I have x pens with me. So you guys see, this is what? This x is what? It is actually just a written statement of some amount of pens that I have. But if I tell you I have some pens, my friend has 2 more than me, and together we have, let's say, 40 pens. So you guys see, if I tell you, I haven't told you that how many pens do I have. I've just told you that I have some pens. So you can see, I can say I have x pens, right? For such kind of scenarios where you have to build up your linear equations, firstly you have to do what? You always have to figure out which part is dependent on which part. Now you guys see, if I assume the amount of pens that I have, then I can say my friend will be having 2 more than that. If I don't assume, if I don't find out that value, what I mean is the number of pens that my friend has is exactly dependent upon the number of pens that I have. If I don't tell you how many pens do I have, you cannot calculate the number of pens my friend will be having, because he is having 2 more than what I am having, right? So that is the point here. Now guys, see, if we do what, if I just tell you I have x pens, so my friend will be having 2 more than me, that means he will be having x plus 2 pens, right? And together we have 40 pens, so that means x plus 2, that is what, that is 40. So you guys see, this is what, this is an equation, because we are getting a finite answer here, we are getting the exact value, which is 40. Now you can easily solve this one. You guys remember how to solve linear equations in one variable, right? So this is the point right here, this is an equation. Now let's get to the point here. So I had told you there that algebraic expression is just a mathematical representation of any statement which involves some quantities, right? It is having a variable, it will be having a coefficient, and it will be having some constant values if they are present here, and that will be what, that will be an algebraic expression. But if you add equality, so a statement of equality involving one or more than one variable, that is an equation. So that is the point here. Now the term is linear equations. So our chapter has the main title, linear equations in two variables, and in class 8 you guys remember you had linear equation in one variable. So what actually is a linear equation? This was told to you in chapter 2 also. You guys remember we had just characterized our polynomials on the basis of their degrees, right? So when we were dealing with the maximum degree, when max degree was 1, we had called that expression a linear polynomial, right? You guys remember we had named that algebraic expression as a linear polynomial. It was something like this: x, 2x plus 1, 3x, 4y, 9xy, right? So sorry, not 9xy, actually 9y, or let's say 90, right? So they were having a maximum degree of 1, and you guys see each of the variable is sharing a maximum degree of 1, right? Now when you had moved forward and you had a maximum degree of 2, that was quadratic polynomial. You are also going to study this one in your class 10. Specifically, you will be having one chapter that will exactly be based on your quadratic polynomial. So you can say quadratic equations, because you will be dealing with the finite values there, and there you will actually be understanding the terms that I had used in chapter 2, which were your zeros, which were your factors, which were your zeros, factors, and what else was there? There was something else. Let me just recall that one and I'll tell you. We had zeros, we had factors, and there was some other thing I cannot remember right now, but that will be here. So variables. What is variable? See, if you denote any alphabet for an unknown quantity, that will be a variable. If you guys remember the example that I had taken, it was this one, that I had some pens with me, right? You guys remember I had given you an example that I had chosen a word some pens. So for those some pens, I had taken a variable, which was what? Nx. So you guys see, any alphabet which is used to denote some unknown quantity whose value is not fixed yet, but if you solve them, you will be getting the finite value there. That will be another case. But since we are talking about variables, so remember this also, while you are dealing with a variable, its value is not fixed. Henceforth, we have the term variable, which means variations. So variations are what? Variations are the change in a value, right? So if I give you a value, let's say if I have something like this, 2x. So if I just put it equal to 2, I will be getting an x, which will be 1. But what if I had something like this? If I had put it against 4, I would have got x equals to 2. So you guys see, value of x is not fixed. It can be anything, but at any given point, it will be fixed for a brief moment. So you guys see, if I had put it against 2, I would have got x1. So that value was fixed. It was 1. But while we chose to have a different value in equality, then the value of x was also different. That is what I was trying to tell you. Variable is just those values which are used to denote some unknown quantity. So I hope you guys are able to recall each and everything. So don't worry, you just have to remember linear equations, and I hope you guys remember everything else from the chapter 2 also. So linear equations is the main topic here, so you guys must be remembering this one. Now let's see what do we have next. So we are talking about linear equations in one variable. So title itself states that we will be dealing some equations which will be having only one variable. Example, guys, just refer back to that case where I had told you that I had some pens, I had x pens, my friend had 2 more pens than I had. So he had x plus 2 pens, and together we had what? 40 pens, right? So you guys see, this is what I'm only dealing with an x here. So this is what, this is a linear equation in one variable. If I want to solve this will be what, 2x plus 2, that will be 40. And you guys see, you can easily solve these. The constant will be pushed on the other side. 2x equals to 40 minus 2. 2x will be 38, x will be 19. So you guys see, I got the answer right here. So you guys understand this one, right? So this was what I was just dealing with, one variable and whose degree was also 1. So remember, the variable that I had taken, it should be having a maximum degree of 1. Then we will be calling that equation a linear equation in one variable, or if that is not an equation, it is an expression, then we will be calling a linear polynomial in one variable. I hope you guys are able to understand this one, right? You don't have any doubt here. So let's just define this one real quick. So definition states exactly what I've told you. When an equation has only one variable of degree 1, then that equation is known as linear equation in one variable. This was the concept of your class 8. You guys will be remembering this one from your, if you were doing your NCERT one, then you should be remembering in your NCERT you had this as your chapter 2, right? You were dealing with this portion in your NCERT, and sorry, not chapter 8, actually under chapter 2. So you had major exercises there. I hope you guys had up till 2.6, right? You had 6 exercises there. In the beginning, you were dealing only with only with your linear equations. You were solving them, getting the values of x and y's. Then you had your statement sums, where you had formed linear equations in one variable by reading the given statements. Then you had your third exercise, where you also dealt with your values, finding the values of x, and you had various things you had done there. So you guys should be remembering how to form linear equations from the statements. If you are unable to do that, I will be explaining it to you later on. So you guys see, in such scenarios, I will be having only one variable. So some examples are here for you guys. See, 3x minus 9, which is equal to 0, 2t equals to 5. You can have any other example like, so this standard form is like this: ax plus b equals to 0, where a and b both are real numbers and a cannot be 0. Since if it will be 0, then if you solve this one, ax equals to minus b, if a can be 0, then b by 0, that is not defined. So it will be a situation of infinity, or you can say a case of not defined, not definite answer. So this will be what we are going to deal here. Now let's see linear equations in two variables. Now name itself suggests to you that we will be having two variables in our linear equation, and both of the two variables will be having a maximum degree of 1. So the general form of linear equation is like this: ax plus by plus c equals to 0. The case here to be noted is that you will be having an x, you will be having a y. There will be two separate terms, but you can never have an xy together in a single term, because you guys should be remembering this one. While you were counting the degree of your polynomials, there had the specific case then while you were dealing with two variables, then you always had to look for that term that was sharing both of the terms. Then you had to add their powers. If that power was more than the degree of the polynomial, then you could have assumed that one as your degree. So here, if you do this one, let me just erase this. If by somehow I had this one, ax plus by plus c xy. Now you can see here, x has a maximum degree 1, y has a maximum degree 1. But in this case, both powers of x and y will add together, then degree will be what? It will be 2. Then it will not be a linear polynomial, because the degree will end up being 2. So remember, this is why your standard form is like this. So standard form is this, and you can see here a is the coefficient of x, quite easy. B is the coefficient of y, and c is your constant term. So linear equations in two variables are like this: minus 7x plus 8y minus 8 equals to 0. Now if you compare these two, if you had this minus 7x plus y minus 8 equals to 0, and if you had compared it to this one, ax plus by plus c equals to 0, then you would have got this. See, x and x, in place of a I have minus 7, y and y in place of b I don't have anything, that means I have just a 1, so it will be 1. And in place of c, I have a positive c, but here I am having a negative 8. So that means c itself will be what? A negative 8, because before c we should be having a positive operator. So these are the things that you guys should be remembering if you have to write the coefficient or the variables for that matter. So this is what we have to do in linear equations in two variables. Remember, in these cases, although what happens is this, guys, we can use linear equations in two variables to solve linear equation in one variable also. See, if you are dealing with some sums, you guys remember this sum, right? There we had this sum that there was a 2-digit number. I guess this was it, second or third sum in your class 8, I don't remember that. But there was this sum that there was a 2-digit number, sum of whose digits let's say was 9, and if you had added what was it, let's say 39 and 63, let's say whatever was there, it was something, and if you had added something, the digits would have reversed, then the number that was formed, it will be greater than this much, right? So those were some situations where you had these kind of questions. You guys remember this one? It was this 63 and 36 kind of this. So you guys see, this was a question in which we had done what? We had assumed a 2-digit number like this, a and b. Then we had this 10a plus b. Then we had expressed this one in the form of c. There actually you did not have done it, did not have do it like this. You have done it like this. You had done it like this. See, you had this, right? Sum of 2 digits were a plus b, that was 9. Then you had taken it like this. I hope you guys had done it like this, right? So you had this, then you had formed the number that was 10a plus b kind of thing. So there we were dealing with only one variable. We were expressing each and everything in one variable, but we could have done that sum with 2 variables also. So this sum will be repeating in your class 10 also. There you guys will be understanding the easiest method to solve this one. But here in our this portion right here, remember, we are not dealing with the methods to find out solutions. We are just dealing with the building up of 2 variable equation and the plotting of those equations on your number line. So here I want to point out one more thing. Remember this is quite important right here. The number of variables that you have in one equation, then you should be having as many equations to solve them. Remember, if I have something like this 2x plus 1, let's say this is 9, here I can easily calculate the value of x. But if I am dealing with 2 variables, let's say something is like this 2x plus y equals to 9. The more variables that you are having, then equal number of equations should be present there in order to find out the finite values of those equations. What I'm trying to tell you, that if I am dealing with 2 variables and to find out the value of those 2 variables, I must have 2 equations there. So if somebody asks you, can you find out the value of x and y for this equation only? Then remember, this cannot happen. You cannot just find out one finite value of both x and y. That cannot happen here because we are dealing with 2 variables, and for solution of 2 variables, you need to have 2 equations. While you are dealing with 3 variables, then you should be needing 3 equations to solve it. If you are dealing with 4 variables, henceforth you can see you should be having 4 equations there. So remember, as you increase the number of variables in an equation, the number of to perfectly solve them, you should be having as many equations as the number of variables are there. So this is an important thing. While you should be remembering that, that will be coming handy in your class 10, and while you opt for your class 11 mathematics there, then you should be using this one in your 3-dimensional geometry, where you will be dealing with 3 variables there. So remember, this is quite important. You should be understanding this one. You cannot solve 2 variables under one equation. So now we are going to move forward and see. So we have some properties of an equation. Now these are the things that should be taught to you earlier in your earlier classes also. So you guys see, same quantities can be added on both sides and same quantity can be subtracted on both sides. This is quite like this. If I have x plus 10, which is equal to 9, if I take this example, let's say if I have x minus 10, what happens here is that I can take this 10 on the other side, then it will be what, x equals to 10. But it's what truly is happening here is that we are just adding 10 on the both sides. You guys remember your trial and error method from your class 9. You guys should be class 7. This was in your class 7 while you were dealing with your algebraic expressions. There you had this method, trial and error method, right? And you had some more methods there where you were putting just values. If you had something like this, x plus 10, that was equal to 9, then you used to do what? To get rid of this 10, you had done this, you had subtracted 10 from here and you had subtracted 10 from here. Later you got the idea, right? In trial and error method, you were just putting the values in place of x and you were having the values. So properties of equations are just telling you that you can perform any operation on your equation, whether it will be your addition, whether it will be on subtraction, whether it will be division, or whether it will be multiplication. But remember, we never do it like this because it is understandable that if we have a negative 10 here, on adding a 10, 0 will become a positive 10 and this 10 will cancel out. So you can just either do what? You can just put this negative 10 on the other side, so it should be a positive 10. So things that you should remember by now, it will be these. If you have something on the left hand side which is negative, on the right hand side it will be positive. that means on the right hand side of equality. If you have something which is positive on the left hand side of equality, then it will be negative on the right hand side of equality. If you have a thing which is in multiplication on left hand side, it will be in division on right hand side. And if you have something which is in divide, then it will be on multiply on the left hand side. So guys, see, these are some situations and these are some properties. While you're dealing with an equation, you should be remembering these. So you can just quickly go through these. See, x minus 10 equals to 0, x will be 10. X plus 5 equals to 0, x will be minus 5. Since this is positive 5, on the other side it will be negative. Now if you have something like this, x by 2 equals to 5, then you can do what? Just cross multiply them. So x will be what? X will be 10. If you have something like this, 7x equals to 70, then it will be what? X equals to 70 by 7, which will be what? 10. So you can perform any operation as you want on any equation. So that is the point right here. That must be noted. Now let's see what do we have now. So we have some practice worksheet right here. Write the following as equation in two variables. So we have to write them in linear equations of two variables. So you guys see how we are going to deal with this one. So you guys see we have to write them in two variables, and I can see my general form of linear equation in two variables. That is what? Ax plus by plus c equals to 0. So you guys see I do have an x, I do have a constant term, but I don't have any y. So can I write it like this? X plus 0y, and this is minus 5 on the other side, that will be what? A positive 5 equals to 0. The general representation of first part, that will be what? Taking the constant on the left hand side, so x plus 5, which in turn can be written like this, x plus 0y plus 5 equals to 0. And similarly here, this will be what? I don't have any x here, I don't have any x here, so this will be 0x plus y. This is positive 2 on the left hand side, it will be negative 2 equals to 0. Then you have this one, this will be what? I do have an x, I don't have any y, so 2x plus 0y minus 3 equals to 0. Now the reason I'm writing 0y, because 0 into y, that should be 0, and our answer is not affected by this, but we have to represent that in two variables. So I have to assume a 0 followed by that variable which is missing. So 0 will be acting as the coefficient, and we can write as many variables as we want with the coefficient 0, because our answer won't be affected on any assumption, because 0 into something is 0. So if you add 0 to anything, your answer will be unaffected. So that is the point here. Now in next part, you guys see I do have a y which is 5y, I don't have any x, so I will be writing it like this, 0x plus 5y minus 2 to 0. So you guys see this will be the point right here. And for the last one, I have been given the equation on the left hand side only. I need to have just a y here. So 3x plus 0y minus 5 equals to 0. Now remember, it does not matter whether you are just using this addition or you are using subtraction. The answer will be same. It won't matter much. If you are not adding something or if you are not taking away something, your answer will still be the same. Now in next part, in second part, we have to do what? We have to express the equations in this form and write the coefficients a, b, and c. So you guys see, firstly we have to compare this equation with that one, and for that we have to rewrite this one. We have to rearrange this one. So you guys see, I do have a 2x, I do have a y which is 3y. This is on the right hand side, I need to have on the left hand side. So this will be what? A minus 9.5 equals to 0. But you guys see, our general equation has a c which is positive, so I have to write it like this. Can I write it like this? 2x plus 3y positive, and in bracket a negative 9.5 equals to 0. So you guys see, positive and negative, it won't matter much, but you guys see our c is having this value and there is a positive sign. So you can just simply compare this one, ax plus by plus c. Now you guys see, in place of a you have 2, in place of b you have 3, and in place of c you have a negative 9.5. So these are the three values. I hope you guys remember this and you don't have any doubt in this, right? So remember this one. Now if I just deal with the next example, we have this one, x minus y by 5 minus 10 equals to 0. Now we have to compare with this one. For that, I'm going to do what? I'm going to get rid of this denominator right here. For this, I'm going to take LCM. So LCM will be 5. You guys see, it will be what? A 5x minus y and a minus 50 equals to 0 by a 1. So you guys see, we can just cross multiply them. So this will be what? 5x, can I write it like this? Plus minus y plus minus 50 equals to 0. Or you can do what? Better, you can write it like this. See, 5x plus minus 1y and a plus negative 50. So if we compare with this one, you will be having an a which will be 5, you will be having a b which will be a negative 1, and you will be having a c which will be negative 50. Understood? So this is how you're going to do them. Now let's just see with the third sum. We have this one. So you guys see we have a negative 2x plus 3y. This is positive 6 on the right hand side. On the left hand side it will be negative 6, which is equal to 0. Now you can just simply compare them. Your a will be negative 2, b will be 3, and c will be what? A negative 6. Easy, because you need to have a positive signs, and you guys see your a will be negative 2. So this is the point. And in second last part we have this one, x equals to 3y. Just take it on the left hand side. So x minus 3y, I don't have any constant, so I can take it as 0. So it should be equal to 0. So you guys see x minus 3y plus 0 equals to 0. So I got a which is 1, I got b which is negative 3, and I got c which is 0, because I don't have any constant here, so c itself will be 0. So that is the point. And in the fifth part, the last part, we have this one, y minus 2 equals to 0. So you guys see we have to do what? I don't have any x, so can I write it like this? 0x plus y minus 2 equals to 0. So a will be what? It will be 0. B will be what? It will be 1, and C will be what? It will be a negative 2. So I hope you guys understand why we have taken 0x, because we had to have an equation with two variables and I was missing an x, so I took it as 0x. So I hope you guys remember this and you don't have any doubt in this, right? So let's move forward. And these are your exercises. So this is your exercise 4.1. This is pretty quick. We have to do this one. So the cost of a notebook is twice the cost of a pen. So you guys see, the cost of a notebook is twice the cost of a pen. So if I have a cost of pen, its twice will be the cost of notebook. So you guys see, we can easily write this equation as a linear equation in one variable, but we have been given that we have to write this equation as linear equation in two variables. So you guys see, they have already given you the hint. You have to assume the cost of notebook to be x and cost of pen to be y. So according to question, you have what? X equals to 2y, or you can say x minus 2y equals to 0. So this is what? This is your linear equation in two variables. Quite easy, right? You can easily solve them. This is the answer. Now in these parts, you have been given the sums here. You have to write them in this form and you have to indicate the values of a, b and c in each case. Quite easy. We have done 5 parts earlier. So you can do this, this is the second part on your own. Just do this one and let me know the answers. You can just match your answer. These are your NCERT questions. Quite easy. You have to do what? Just take your constants on the left hand side, compare with this equation and write down the values of a, b and c. Quite easy. You can easily do these. So I will be leaving these to you, and let's move forward with this one. So now we are talking about solutions of linear equations. So what is actually a solution? If I just give you an example here, if I had something like this, 2x plus 1, that was equal to, let's say, a 5. Now what solution means? It means that you have to assume some value of x. After replacing that value, both your LHS and RHS must be equal. It should be satisfying this condition. Now for calculation of solutions, you do what? You can use your hit and trial method. That means you will be assuming the values of x. Firstly your 1, then 2, then 3, and at any finite value of x, if your LHS turns out to be same as your RHS, then you can say that finite value of x will be the solution. That is the case of solution if you are dealing with what? If you are dealing with just one variable. Remember, I had told you earlier that if you are dealing with more than one variable, then you need to have more than one equation to solve them. So if you are dealing with two variables, then you must have two equations to solve them fully. There you will be getting the finite values of your x and y. But if you just kind of want to answer or find out the values of your x, if you have an equation which deals with two variables, but you have been given only one equation, then remember, for this case, you will be using the assumption method that we are going to discuss later on. For that case, we will be assuming a value of y, then we will be getting a value of x, then we will again be assuming another value of y, then we will be getting another value of x. So this is how we are going to deal while we are having just one equation, when we have to find out some solutions of the equation. So remember, if you are dealing with an equation which has more than one variable, then remember, there can be infinite solutions. There won't be just one solution, there will be infinite solution. But if you are dealing with a linear equation in one variable, remember, there can only be just one solution. So if you just focus on this example and forget that one, let me just erase this one because that is the concept of the later video. Let's just firstly understand what solution means. So if you just focus on this equation right here, you guys see you have to assume a value of x after being multiplied with 2 and added to 1, you should get a 5. So I can see I can take an x which should be 2. So 2 into 2, that should be 4, 4 plus 1, that will be 5. So x equals to 2, that is the solution of this equation. Now you can assume any other value as you want, but you won't be getting any 5. You can assume that value on your own. You can assume any value apart from this one. So you won't be getting a 5 right here. So remember, this will be the point. So remember, a solution is that value of variable which satisfies both your LHS and RHS such that they become equal. So that is the point to be noted here. So solution is this concept. I hope you don't have any doubt in this, right? Now let's move forward and see what do we have now. So solving an equation, you guys remember, if you are dealing with a linear equation in one variable, then you will be having only one solution. You can consider this example, 2x plus 1 equals to 5. So this was what? 2x equals to 4, x will be 2. So there was only one value. But if you are dealing with a linear equation in two variables, see, if you are dealing with linear equation in two variables, there can be infinite many solutions if you are doing what? If you are doing it like this, if you are just having single equation. But if you are dealing with more than one equation like 2x plus y equals to 3 and let's say 3x plus y equals to 7, then you can do what? You can use the elimination method, that is for class 10, but you can use them and you can get the answer. So that is the point to be noted here. While you are dealing with a single equation and that has more than one variables, that will be having infinite many solutions. So this can be asked in one mark question. So remember, if there is one variable, solution will be 1. If there are many variables and equation is just 1, then solution will be many, that means infinite. So a linear equation in two variables has a number that can satisfy, has a pair of numbers. See, it will be having two values of x and y. After putting those values, that will be satisfied, the equation will be satisfied. See, if I have this x plus y equals to 9. Now how many conditions can be there to satisfy this? So you can see it will be this minus 1 plus 10, that will be 9. A 1 plus 8, that will be 9. A 2 plus 7, that will be 9. A minus 2 plus 11, that will be a 9. So you can see there are many values to satisfy this condition. So for generally, while we are dealing with the solutions, we always construct a table and point out all the values that can happen there. Since the values are infinite, the solutions are infinite, so we mostly just consider two values or more, three values, where we should be having an x0 and another one will be y, and where we will be having a y0 and another one will be x. If we have these two values, then we won't go further. We will be just pointing out all the area that is lying under these 2 points. So remember, if there is a value which has, if there is a coordinate in which we have just y, not an x, so that means that point will be lying on our y axis. And if we have only x and we don't have any y, that point will be lying on our x axis. So that will be the point to remember. So this will be the case, right? Now let's move forward. So here we have to do what? You have to just remember this one. So some concepts from our earlier classes. You guys remember, if you have any value that is equal to x, let's say it is x equal to a, so line will be parallel to y axis. And remember, if you have been given any value for y, let's say you have been given something like this, y equals to b, then line will be parallel to x axis. Now you can see here, if I have, let's say x equals to 2, 1, 2. So line will be parallel to y axis, so it will be x equals to 2. And let's say if you have something like this, if you have y equals to 3, so this line y equals to 3, that will be parallel to your x axis. This is y equals to 3. So here you should always be, you should also be remembering this one. If you want to plot any point on y axis, then it needs to have a your coordinate like this, 0, a form. And if you want to plot any point on x axis, then it needs to have a coordinate like this. Sorry, this will be a, 0, kind of this, right? And you guys already remember, in this case, a will be what? A can have both positive and negative values. So either it can be a 0, a positive a, that should be upward of origin on the x axis, positive y. If you are dealing with a 0 and a negative a, that will be on the negative y. Similarly, a, 0, positive x, negative a, 0, negative x. So these are the things that you should remember. We had discussed this one in the chapter 3. So I'm going to move forward and see what do we have now. So we have to write 4 different solutions of this equation. Now for finding out solutions, I had told you that earlier we had to do what? We had to just assume one value and get the value of other. For this one, we are going to do it like this, exactly the way we are going to do now. X plus 2y equals to 6, right? Now do what? Just take x here and put this 2y on the other side, 6 minus 2y. Now do what? Start assuming the values of y. Firstly do what? Assume the value of y, or you can do what? Let's just keep it like this. Let's just not go there. Just let the equation be written like this. Do what? Let x equals to 0. So if you put x0 plus 2y, that will be what? That will be 6. Now we have to find out the values of x and y. After putting those values, this equation will be, both LHS and RHS of this equation must be satisfied. So you guys see, 0 plus 2y, that will be 6. So 2y will be what? It will be 6 and y will be 3. So if x is 0, y is what? Y is 3. Now if I do what? If I assume y 0, so I'm going to do what? Let y equals to 0. So you guys see, x plus 2 into 0, that will be equal to 6. So x will be what? It will be 6 minus 0. So x will be, sorry, this will be, let's just end it here, not make more steps. So x plus 2 into 0, so x plus 0, that will be 6, x itself will be 6. So when you had y0, your x was 6. So you have two values here, a 0, 3 and a 6, 0. So these are the two solutions from many infinite solutions of this equation. You can have any other solution as you want. See, you can have x2 and you can have y2. See, 2 into 2, 4, 4 plus 2, that will be 6, and you can have any other values. Now you have to do what? Let's just make a table and write the values here. So when we had, let's just make up a table here. We had two values. This is x and y. So when we had x0, I got the y, which was what? It was 3. And when we had y0, I got x, which was 6. Now we have to do what? These are the solutions. Later we are going to study them. We are going to plot them. So we have to find out 4 solutions. We had 2. Now let's move forward. Now I'm going to do what? Let y equals to 1. So x plus 2 into 1 equals to 6. X will be what? 6 minus 2. X will be what? X will be 4. So you have this one. When you have x4, y is 2. Sorry, y is 1. Right? We had assumed this one as 1. So when we had x4, then y was 1. Then we can do what? Let y equals to 2. So x plus 2 into 2 equals to 6. X plus 4 equals to 6. X is what? X is 2. So you guys see, when x is 2, y is what? Y is also 2. Right? So these are the 4 solutions of this equation. Now similarly, you can find out as many solutions as you want. You can find out even 100 solutions of this equation. Since we are only dealing with one equation and there are 2 variables, so it will be having more than, it will be having infinite solutions. You can just find out as many solutions as you want. Now let's move forward and see what do we have. So we have to write 2 solutions in each of the following equations. So let's just pick our first one. 4x plus 3y equals to 12. Now you guys know the drill. What we have to do? We have to just assume one value and get the other. So let's say let x equals to 0. So 4 into 0 plus 3y equals to 12. So 3y equals to 12, 4 being, this being 0. So y will be what? Y will be 4. So you guys see, when x was 0, y was 4. Now let's do what? Let's just assume y equals to 0. So if I assume y equals to 0, 4 into x plus 3 into 0 equals to 12. So 4x equals to 12, x will be what? X will be 3. So when x is 3, y is 0. So these are the 2 solutions. Now in this case, if you assume x 0, your y will be 0. If you assume y 1, then see what do you have? Let's see. So let me just erase this and let's focus on our second part. So we have this one, 2x plus 5y equals to 0. Now you don't have any constant right here. You just have a 0 here. Not constant other than 0. Remember that. So 2, let x equals to 0. So 2 into 0 plus 5y. That will be 0. So 5y equals to 0. Y will be what? 0. Now we are going to do what? We are going to assume x equals to 1. So 2 into 1 plus 5y equals to 0. So 5y will be what? A negative 2. Y will be what? A negative 2y. Right? Because this 2 is positive, on the other side it will be negative. This 5 is in multiplication. It will be in division. So 2 solutions are what? 0, 0 and 1 comma minus 2y. 5. So these are the 2 solutions right here. And for this one, you have to write 2 solutions. For this case, you can see if I erase this one, so 3y plus 4 equals to 0. Now guys, see here you will be getting this one value of x. It will be what? Let's see. If I just put it here, this will be 3y equals to minus 4. Y will be what? Y will be minus 4 by 3. So you have 0 comma minus 4 by 3. Because you don't have any x, so you can just not have that value, but you can do it like this. 0x plus 3y equals to minus 4. Then you can say if you have taken x1, this will be 0, but y will be what? It will be 1 by minus 4 by 3. So it can happen like this. So your line will be what? You are sharing the same y, you are sharing the same ordinate, then your line will be parallel to what? It will be going on like this. See, if you plot this one, you guys remember this. See, you had something like this. So if you're dealing it like this, let's say this is the point minus 4 by 3. Initially this will be 0 comma 4 by 3 minus 4 by 3. Then this will be 1 comma minus 4 by 3. This will be minus 2 comma 4 by 3. So your solutions can be as many, but your y will be fixed minus 4 by 3. So 0 comma minus 4 by 3, 1 comma minus 4 by 3. So you can write as many values as you want. So these are the some of the solutions that you had to write. You can write any other solutions as per your calculation. So I hope you guys understand this and you don't have any doubt in this. Right, now let's move forward and see what do we have now. So this is the exercise. You have to just write the answers. Which of the following option is true and why? Y equals to 3x plus 5 has a unique solution, has two solutions, has infinite many solutions. Now guys, see you are dealing with just one equation, but you have two different variables, so it will be having infinite many solutions. Now you have to write 4 solutions in each of the following. You can easily do this one. Just do what? Put the value of y, get that value of x, then change the value of y, get the new value of x, again change the value of y, get the new value of x. Similarly, in this one, let me just do this one for you. Pi x plus y equals to 9. Just assume your x 0. If x is 0, y will be 9. So 0 comma 9, that is the first. Then if you assume it to be, if you assume y to be 0, if y is 0, then x will be what? 9 by pi. Right? You can write as many values as you want. Now, the third question is very important. Remember this one. You have to check whether the following solutions are the solution of this equation. You have to check whether after substituting the values of x and y from these coordinates or these solutions, whether they satisfy this equation or not. Now, you guys remember, if you have to check the satisfaction of an equation, you need to have your LHS same as your RHS. So, remember this is your x and that is your y. So, after substituting the values of x and y for every value here, if you get your LHS that is same as your RHS, then you can say it is a solution. If you do not get that value, then it is not a solution. Like in a fourth part, see, our x is what? X is square root 2 and y is what? Y is 4 square root 2. So if I put it here, I have what? Square root 2 minus 2 into 4 square root 2. So guys, see, square root 2 minus 8 square root 2. This will be what? Minus 7 square root 2. Right? So this is not equal to 4. This is not a solution. I hope you guys remember this and you don't have any doubt in this, right? So this will be the point to be noted here. I hope you understand this one. Now in fourth part we have what? Find the value of k if this is a solution. If that is a solution, then after putting the values of x and y, the answer you will be getting will be same as your k. So 2 into 2 plus 3 into 1, that will be equal to k. So k will be what? 4 plus 3, k will be 7. Right? Easy. You have been given that it was a solution. So it was quite easy. I hope you guys understand this and you don't have any doubt in this, right? So now we are going to deal with our graphs and see. Now plotting is quite easy. You guys remember, if you had to plot a linear equation in one variable, like you guys remember, I had already told you that if you want to plot an equation where x is given to you some value, let's say x is equal to a, then the line will be what? It will be parallel to your y-axis. And if you had been given a value of y, which was let's say a b, then the line will be parallel to your x-axis. So these are the things that you should be remembering while you're dealing with one variable. Now in the case of two variables, you have to do what? You just have to plot those solutions that you have got from that equation. Like in this case, remember, here we had these solutions, right? In this part, we had some solutions, right? So you can just do what? Your first one is x, second one is y. You can easily plot them on the graph and you will be getting the graph form of a linear equation in two variables. So if you had to plot your first, you had this one, right? 0, 4 and 4, sorry, this was this, right? Yeah, 0, 4 and you had a 3 comma 0, right? So you had these two solutions. So when you had to plot them, you will be doing what? Drawing a graph. 1 2 3 4, 1 2 3, 3 comma 0, that will be here. 0 comma 4, that will be here. Just join together. This will be the line of the equation, which is 4x plus 3y equals to 12. So this is the graph form. I hope you guys remember this. So this is how you're going to make graphs. So this is what has been written here. So we have to draw the graph of this equation. Now we have already plotted this one, but here we have 3x plus 4y, which is equal to 12. Quite easy. Just assume your x 0, let x equals to 0. So we have what? 3 into 0 plus 4 into y equals to 12. 4y equals to 12. Y will be what? Y will be 3. So if I make a table right here, when I had x 0, my y was what? Y was 3. Then I do what? I assume let y 0. Then this will be what? 3x plus 0 equals to 12. X will be what? X will be 4. So when y was 0, x was 4. Now you can easily plot this one. So I'm going to erase this and let's plot the values. You guys already remember I've already plotted this one, but I will be doing it again. So it will be like this. Just plot the values. Maximum value x is 4, 1, 2, 3 and 4. Maximum value y is 3, 1, 2, 3. So 0 comma 4, that should be this one. 4 comma 0, that should be this one, and 0 comma 3, that should be this one. So this will be the line of equation 3x plus 4y equals to 12. So you can easily represent them on graph. So this is how you're going to do this one. So graph of lines parallel to x or y axis. So if a line is parallel to x axis, then y will be what? If a line is parallel to x axis, then y will be having some value. If a line is parallel to y axis, then x will be having some value. So these are the things that I've already discussed in an earlier part of this video. So I'm going to move forward. So linear equation statements. Now we are going to study how we are going to make statements of the linear equations. So remember, if you are going to make linear equations of statements, you just have to assume one value as your x and another value as your y. If they have asked you to make a linear equation in two variables, if you are just dealing with one variable, then you can use just one variable. Then you have to look for that dependent part on which everything in your question depends upon. So you guys see now this question, the auto rickshaw fare in a city is charged 10 per for first kilometer. See, let me just, yeah, sorry. So it is 10 for first kilometer and 4 per kilometer for the subsequent distance covered. Write the linear equation to write above statement. So you guys see, there is a rickshaw driver, let's say he is charging something, he is charging 10 for first kilometer. Wherever you go, for every first kilometer that you have traveled, every first kilometer, he is going to take 10 rupees and 4 per kilometer later on. So you guys see, if I assume variable cost, or you can say if I assume the distance after first kilometer, see, for first kilometer he is taking 10, and every distance after that, for every kilometer he is taking 4 rupees. If I tell you, if I just assume that distance after first kilometer, that is y, then cost will be what? 4 times of y, it will be 4y. And let's say if I assume total cost is x, or total fare, let's just say total fare. So fare here as well. So total fare is if rupees x, then according to question we have what? Total x will be equal to cost of first kilometer, then the variable cost. This is the linear equation in two variables, right? He is taking 10 rupees for first kilometer and 4 per kilometer after that kilometer. That means after first kilometer he will be taking 4 rupees. So for first kilometer, that is 10 fixed, and after every kilometer that you travel, he will be taking 4 per kilometer. So total fare after 1 kilometer, that will be 4y, and exactly total fare, that will be 10 plus 4y. Now you can easily draw the graph of this one. So you can just assume the values and draw the graphs. This is quite easy. Now you guys see, we have this one. The force exerted to pull a cart is directly proportional to the acceleration produced in a body. So you guys see, force is directly proportional to acceleration. Force is equal to mass into acceleration. Because you guys will be learning this one. So you guys see, write the expression in two variables. So you guys see, I have this one. Force and acceleration are the two variables. They are directly proportional. Then it will be what? If I remove the proportionality, there will be some constant. You're going to learn this one in your science. So F will be equal to ma, right? where acceleration is not fixed and force is not fixed, but whatever the mass of an object, that will be constant. So you guys see, you have to draw this graph and you have been given that constant mass is 6 kg. So force is actually equal to what? 6a. Now you can write as many solutions as you want. Now you have been given that you have to write out the solution. Your acceleration is 5. So force will be what? 6 into 5. It will be what? 30 newtons. Then you have what? You have been given 6 meter per second square. Then force will be what? 6 into 6. It will be what? 36 Newton. So if I draw the graph right, if I draw the table, construct the table. So I have force, I have acceleration. When acceleration was 5 meter per second square, then force was 30 Newton. When it was 6, it was 36. So you can just plot them. So remember, when there is the case of direct proportionality, remember, proportionality means if you increase one value, another value will be increasing. If they are in direct proportion, if they are in inverse, then the statement will be written like this. If there had been some case like this, then it would have been force upon area. So it would have been proportional like this, where A would have been area. So this is the thing that you should be remembering. So while you remove your proportionality, you should be multiplying with some constant values. So remember, this is the concept of your physics. You will be understanding this in your force and pressure. But for now, remember, this force is equal to mass into acceleration. So we have these. You have to draw graphs of these equations. So you can easily do these. So I hope you have understood each and everything. And you have to draw these graphs and you have to verify this point is lying on this one. Just do what? Plot the values for x and y. And if that's you have been given that if this point is lying on the equation of this, you have to find the value of a. Quite easy. Just replace your x as 3 and y as 4. So 3 into 4 equals to a into 3 plus 7. So this will be what? This will be 12 equals to 3a plus 7. 3a will be 5. A will be 5 by 3. So you got the value of a. Now in second part you have what? Give the equation of two lines passing through this point. Now you have to do what? Give the equation of two lines passing through this point. Now you have to write equation of two such lines that should be having this as coordinate. Now you can do what? You can assume it like this. Let's say 2x plus y, and let's just assume this one. If I just put 14 here and if I put 2 here, so 2 into 2 plus 14, that will be what? 18. So let's say its answer is 18. You have to generate an equation in which if you replace these values, your equation should be satisfied. You guys see, 2 into 2, that will be 4. 4 plus 14, that will be 18. So I got the answer. Now if I assume this one, x plus y, now you guys see, 2 plus 14, that will be what? That will be 16. Quite easy. You have these. Now here you have to understand how many more such lines are there and why. So remember this one. If you are dealing with a single point, you can pass as many lines as you want. See, just ignore this one. This is not straight. So if a point is singular, if you have just one point, you can pass as many lines as you want from that point. But if you are dealing with 2 points or more than that, there can only be one line that can pass through these 2 points. Remember, if there is any other line which is passing like this, that is not a line, that is a curve. So this is the concept of your class 7. So I hope you guys remember this. So how many such lines will be there? You guys see, I am dealing with only just one point. There can be infinite lines. If there are infinite lines, then there can be infinite equations. So I hope you guys understand this. This is quite easy, and we are going to move forward. And this is the question. So we are going to move. We are going to have this one tomorrow while we study some examples also. So I will be having these questions later for tomorrow. We will be having a practice session. That means on Monday. Tomorrow is Saturday, right? So on Monday we will be having practice session. I will be having these remaining questions then. Since our class is almost getting lengthy, so this is almost 1 hour. So we are going to pick up these questions on Monday along with some extra questions. So we will be having some practice question then. Till then, practice as much as you can. And we have learned whatever we have learned in this case. You guys should be remembering this. So we have learned about a linear equation in one variable, linear equation in two variables. Their plottings that can happen if we have coordinates like this. So remember, we have learned up till plotting, and that is what we have to understand till this portion, till our chapter 3. While you are in class 10, you will be learning about the finite solutions. But for now, you just be remembering plotting. So I'll see you in the next part, which will be on Monday. Till then, practice as much as you can. I'll see you then.